Recording rolling. It's Friday, February 7th. So you guys remember AP night's coming up in a few days. If you want to talk to 8th, 9th, and 10th graders and get them possibly interested in AP or if they're considering that, then go talk to Mr. Davies and he might give you a spot on AP night in a few days from now. So you guys know today I'm pretty much giving you guys the whole class period to work on these chapter 9 puzzles. Okay, so you guys can work by yourselves or work with your friends, or if you're really stuck on something or have a question, then let me know. Okay, so one of the signs, guys, you guys remember to flip this whole packet over on the back, fluids warm up number 6 through 11. Everybody do number 6 through 11. That is basically check all the boxes, the main ideas going on in this section. Okay, want everybody to do number 38, try to figure out the density of this object that's being held from the scale and dunked in the speaker of water. Okay. And then I had you guys each pick 3 additional puzzles out of a box yesterday. I want you guys to check my solutions because I came up with some solutions a few weeks ago. Of course, I posted those like I always do, but not 100% sure. I didn't make a mistake in somewhere. So you guys check and make sure that I'm getting everything right. Also, AP Classroom Unit 8's been open for about a week now, I think. So have those done by Monday morning so we can go over the solutions then. All right, so here, give you guys a real fast recap of some concepts you guys have seen this week. So for a mnemonic device, I might recommend ABCP. If you can remember ABCP, that should check most of the boxes for this section. That's going to stand for Archimedes, Bernoulli, Conservation of Flow, and Pascal, right? Because they show principles on, right? All right, so the posters have gone on with these. Archimedes principle talks about the magnitude of this buoyant force. Now you guys know what buoyant force pushes upward if something's submerged in a fluid. Okay. That buoyant force is equivalent to the weight of the displaced fluid, which further breaks down like this, rho Vg. Right. That rho density, you guys know it is an intrinsic property of matter. It's the ratio of mass to volume. So iron has a density, aluminum has a density. The density of water is, guys, what's the density of water? Okay, yeah, 1 gram per cubic centimeter. Well, let's go 1,000 kilogram per cubic meter if you're working in base SI units. So it'd be 1,000 kilogram per cubic meter. Okay. All right, so here's Archimedes principle, the magnitude of the buoyant force, rho Vg. Here's pressure. The deeper you go, the more pressure. That's rho Gh. Those are really similar looking formulas. Okay, one's a force, one's a pressure. Okay. Here's those two. Iceberg classic question. What percentage of an iceberg is submerged underneath the water? Right, well, it ends up being a ratio of these densities. Right, so now look at that one. Look at that one. U-tubes are classic questions in this section. Okay, so you guys know the pressure builds up rho GH. So by the time you get to say this line down here, coming from the left arm and the right arm, it's 2 different stories of how you got to this pressure down here, but it has to be the same pressure. So that's an equation. Okay, the left side, the right side, same pressure. Okay. So there's variations on this. My YouTube is open to the atmosphere at both ends. There's variations where that's not always the case. Right. So like my pressure cancels out of the air pressure. But yeah, it's a little different. Watch for that. You guys know, here's Pascal's principle. Okay, so pressure is transmitted diminished. Pressure is force per unit area. So a small force on a small area can lift a large force on a large area. Okay, the hydraulic lift right there. Here's your conservation of flow. So the flow rate throughout a pipe system is the same everywhere. So cubic meters per second, volume per time. And that's going to break down to this cross-sectional area times speed is the same everywhere in the pipe system. Okay. Actually, this gold box is really the one you guys care about because water is basically not compressible. Okay. Now, if you did have a compressible situation, which I don't think you'll see in this class, but maybe in college or the future, okay, if you have steam going through the pipe, that might be more compressible. You would have to consider the density of the fluid. Okay. But again, for this class, just A1V1 equals A2V2 should do the trick. Okay. Also in that pipe system, I bet the pressure is changing. Okay. And even if it's just a flat horizontal pipe system, here, see if you guys remember this. Guys, going from the big pipe to the little pipe, does the water speed up or slow down? Speed up. Yeah. Speed up. And what it does, because there's a fish going through. What happens to the pressure?
It drops.
Decrease. Yeah, the pressure drops going from left to right. The pressure drops. Okay. You can also have a height change that also contributes to a pressure change. So the question that handles that is called Bernoulli principle, right here. Okay. If I blow over the top of the paper, it vacuums the paper up because it's an extreme air. Okay. Bernoulli principle is also involved in like how do planes fly? Right, now it's not all Bernoulli principle, but part of it is, right, so if you shape the wing, so it's like flat on the bottom and curved on the top, right? Then when that's plowing through the air has to move physically faster over the top to meet up with the air on the bottom, right? So there's a pressure differential there, right? That's part of what helps with plane glide, right? Okay, yeah, okay, I think it's the main ones that you guys care about there. All right, so I'll give you guys the rest of class today to work on those puzzles. If you guys have any questions, then let me know.